Hello and welcome to grade 10 math. We're in unit 3 of quadratic relations, and we're focusing on uh, factoring. And today's lesson is factoring a special type of expression called a difference of squares. Um, so by the end of today's lesson, we'll recognize a binomial that can be factored using a difference of squares, and we'll factor using difference of squares skills, and we can solve some problems with that as well. So let's just recap. Before we introduced factoring and simple factoring last lesson, so we wanted to recap with that. So we looked for a GCF, and so we see x's are in both, so you take the lowest value of the x the 1, and that makes common to both. And a 2 and a 1, well, I think it's just 1. 1 goes into 1 and 1 goes into 2. So if we were to factor that out, and then again, it's putting in this in terms. When it says to put in terms of length and width, we're really just looking for two factors, and usually it's the number, the monomial in front and the binomial inside the brackets. So if we remove 1x, and we go 2x squared plus 1x, because that's a 1x right there. And remember what we did last lesson, we divided those, right? So for whatever we're putting here, we end up dividing it out at the bottom. So, and then we think about reduction, and we say, well, this will go into this once and once. This will go into this and reduce that to there, and that can be simplified. So area equals, now again, nothing changed here. We can change this to just saying x. We don't really need to say 1x. And what happened here was it's left with a 2 and an x, because after we clean all that up, that's all that's remaining. And then after we reduce these, all we have is a 1. And so that's what we end up with. So if area is length times width, then one of those is length and one of those is width. You could assume that 2x plus 1 is longer than just an x because it's at least 2x. So we could say that the length, therefore, the length is expressed as 2x plus 1, and the width is x. So, because we just put those right from here. All right. Very good. Okay, we're ready to go into the lesson now. Now, we have to be really familiar with our perfect squares. And we used before, last lesson, we brought up a times table. You can pull these up pretty easily yourself on the internet and quickly glance. You can print one off if you thought it was helpful enough. Usually in class, you'll get a copy. But look at this, the yellow highlighted ones down the middle. Those are all perfect squares. So 1 times 1, 2 times 2, 3 times 3, right? 4, 9, 16, right up to 100. There's even up to 44 is next. Okay, so it's good to have these in mind when we move into our lesson. So the lesson is, well, again, what are these perfect squares? So one, the 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, and so on and so forth, up to even 15 times 15 is 225. So all these, this chart will come in handy. We probably don't need that times table after all. But so also the idea that a perfect square is just like what it sounds like, a square that is perfect. Well, you can only have a perfect, you can't have a imperfect square. Squares are always the same width by the same length. So the difference of squared means that we're subtracting. Okay, so let's say, for example, we had, um, you know, x times x as an area, right? Well, that would be x squared. What if you had something like x to the power of 5 times x to the power of 5? That would be x to the power of 10. So keep that in mind too, that our exponent laws tell us that we add those fives. More examples, like x squared times x squared is x to the power of 4. So we get the picture here. Okay, so the difference of the squares means subtraction. This means that our brackets are going to look like this. X minus a times x plus a, where a is the same term. Okay? So, in other words, a squared equals a times a. So, the difference of square means subtracting two perfect squares. So, now that we know how to expand using FOIL, we can do this. All right, so we'll take our first example here. If we were to work this out, all right, x times x is x squared, x times negative 2 is negative 2x, 2 times x is positive 2x, and 2 times negative 2 is negative 4. Again, we have common like terms here, so we're left with x squared plus 0x minus 4. Well, of course, 0x, we don't write that, so it disappears. And now what you have is a binomial. But it really is a trinomial. It really is a trinomial like we saw in our foils, but it happens to be a 0, so it ends up canceling out. So you really have to look for these. These are going to happen, all right? So we can work our way backwards here and say, you're going to see a way of doing these. So you're going to say, okay, what is 1x, what is x squared, and what is negative 4? Actually, not even the negative. The negative kind of goes on its own. So we're going to have negative 4. And what I want you to do on these, here's a hint and a shortcut. As long as you recognize that you go, wait a second, 1 is a perfect square and 4 is a perfect square, right? Both are two perfect squares. All right, so what we do is we square root this and we square root this, but we keep the negative in there. All right, so if we square root this, we have x. And if we square this, we have 2. All right, but we have to make it so that it cancels itself. So we're going to have x plus 2. So these two will cancel, right? So in the end, it's even easier than that. I know my explanation is making it sound more complicated, but all you need to do is like we did up here. Once you know what your x is and once you know what your a is, you just plunk them in. We know the a's are the 2 and the 2. So it's x minus 2 and x plus 2. All right, so if you foiled this out, in the middle step, uh, you would end up canceling out these 2's and you get the nothing in the middle. Okay, so here we go with this one. Can we foil? Now, some of you guys like the grid, and we got away from doing that. So let's try doing the grid version. X minus 6 and x plus 6. So x times x is x squared. X times 6 is 6x. Negative 6 times x is negative 6x. And negative 6 times 6 is negative 36. Of course, when we combine these ones, they're going to cancel. So what are we left with? Well, we're left with x squared right here and minus 36. So again, if you look at these, you see two perfect squares. So take your numbers, x squared and 36, and square root them. Okay, and you're going to get x and 6. So x plus or minus 6, basically. So it can be two things. It can be x plus 6, x minus 6. Same as what we started with. Okay, let's take up some examples now. And there's a couple of things we wanted. There's a reason why we teach these in the order we're teaching them. And the first thing is that we want to look for common factors in all cases. Then we want to look for perfects of squares. So first, or difference of squares. First, inspect for common factors. Second, inspect for difference of squares. Okay, and then third, of course, third would be make your equation. Okay, so first, there's a 1 here, so is there a common factor? Not really. There's no x here, so there's no common factor. Well, the only common factor would be 1. So the next thing is inspect for a difference of squares. So we have a perfect square of 1 and a perfect square of 25. So square root of x squared and square root of 25. And what I want you to put in the middle is a plus and a minus, because it can be either, right? You could get positive 5 plus positive 5 is 25, and you can get negative 5 times negative 5 is positive 25. So you would have x, and you would have a 5, plus or minus. All this means is that we can write it twice. We can say that the equation then is x plus 5 and x minus 5. And those negatives will end up canceling in that middle term. All right. So what about the next one? So first, inspect for a common factor. Okay, well, we have this 4 in front. That's a big hint. Okay, 4 goes into both. So we have a greatest common factor of 4. So divide both sides by 4 and put the 4 outside. So 4. And so what is 64 divided by 4? It is 16. And then 4 divided by 4 is 1, x squared. Now ask yourself, do we have a difference of squares? Yes, 16 and 1. Okay, so don't forget this 4 out here. So the square root of 16, I'll do this sort of in separate colors here. Square root of 16 and the square root of x squared. Well, that would be 4 and x. So that's what's going to go in our bracket. Now the problem is we have this 4 outside. So we still have the 4 out there, but the thing is we make a double bracket anyways, because we still have this other new expression. The other thing that we haven't seen is we've never seen an x squared come second. And that usually happens when it's a negative, because it just looks nicer. We don't want to start with a negative on the front. So you'll see that very common. So we have x and, oops, I should put it like in the order that we did. So we should have 4 and x and 4 and x. And the only thing you're going to do different here is change the signs in between. All right, and then that's it. That's how far it goes. All right, let's hopefully we're getting the hang of this. All right, do we see any common factors first? So do we see a GCF first? Well, definitely. Okay, so I mean, you got to know your multiplication tables really well, but 9 and 81. So we know that 9 goes into 9 once, and 81 it goes into 9 times. So we have a GCF of 9. So we are going to divide both sides by 9. That gives us a 9 in front. And by the time we cancel, we have x squared minus 9. Okay, so 81 divided by 9 is 9. Then we say, do we have a difference of squares? Yes, x squared and 9 are both difference of squares. So, what is the square root of x squared? What is the square root of 9? X and 3. Those are your two numbers. Okay, so x plus or minus 3. So don't forget about your 9 now. Your 9 still is there. 9. The thing you're going to do is make two brackets here. And you're going to say x and 3 and x and 3 and just make them different signs. Okay? Let's say you wanted to check whether this was right or not. We could do a check. 9 times x plus 3, x minus 3. So don't do anything with the 9 yet. X times x is x squared. X times negative 3 is negative 3x. X times positive 3 is positive 3x. And 3 times negative 3 is negative 9. Of course, these cancel out. What are we left with? 9 times x squared minus 9. Okay, if we were just to distribute this, we would get 9x squared, and distribute this one, we get negative 81. And that's it. It matches. So correct. Good. All right. Now we have a long word problem. So Silva wants to use an area of her backyard for a garden. The area of the backyard is 9x squared, and she wants her garden area to be 16 meters squared. Okay, so the area of the backyard is represented by 9x squared. She wants her garden to be 16x squared. Write a quadratic expression that represents the remaining area of the backyard. So you could kind of imagine this as she has this big area, and it's 9x all of it, and she wants to map out a garden that is 16 meters squared. Okay, so really we have the total, subtract the little corner here. So her area of the back of the remaining area would be her total area minus the area she wants for her garden. And there's an expression. So that's all we needed was an expression. Okay, how can we determine the dimensions of the rectangle with the same area as the remaining area of the backyard? So imagine if that was its own space as a rectangle. So a new area. right? 9x squared minus 16. Okay, I don't know why someone would want to do that exactly, but there's lots of different configurations you could do. So 9x squared minus 16. Again, going back first, is there any GCFs? 3 and 3. 3 doesn't go into 16. 9 doesn't go into 16. So GCF, there's none. Other than 1, of course, but 1 doesn't really count. All right, so then we look for perfect squares. Here, 9 is a perfect square. 16 is a perfect square. Okay, so square root of 9, x squared. They're both, actually. This is actually a bit unique because we haven't seen this yet. We have a square root of 9 and a square root, perfect square of 9 is perfect square of x squared. So plus and minus square root of 16. So we will have 3, because square root of 9 is 3, square root of x squared is x, and plus or minus 4. So we can then take this and say area equals, and make 2 brackets. And the brackets are going to be these numbers. So 3x plus 4 and 3x minus 4. And that's it. That's our expression. Okay, so 2 binomials to be put in. That's our dimensions. So we would say, therefore, the length is 3x plus 4, and width is 3x minus 4. Now I made the width minus because the one with the minus because it must be taking away and this must be gaining. So the length must be a little longer. Okay, then we get in here and it says what are the actual dimensions if x was actually equal to 3. So substitute. So length equals 3x plus 4. Width equals 3x minus 4. So 3x times the new x value of 3 plus 4 is 9 plus 4 is 13 meters. Okay, 3 times 3 minus 4. 9 minus 4 is 5 meters. Very good. So therefore, the length is 13 meters and the width is 5 meters. So we actually, yeah, so now that you know to how to recognize common factors and to recognize difference of squares, you can point these out really fast. You can jump right to the answer just by doing what we did where we square root those numbers. Okay. Thank you for joining in, and we'll see you next time.